cross product of two vectors. I mean, cross product is not a new thing. Dot product and cross products are not new things. We are not going to discuss that. No one knows. Everyone knows dot product and cross product. But idea is that slowly we'll move toward from vector to calculus, and we started the discussion from the local linearity and then chain rule. And now everything what we are, so whatever we are discussing now, the vector and then dot product and then cross product, then it will be followed by calculus and so many things. Now everything is component wise. So how, if we have orthogonal components for any class, so class has attribute and all attributes are, if they are orthogonal to each other, then they save space, and whatever the net volume what we get with the kind of doing some permutation combination of the orthogonal component, that would lead to the maximum information. So vector is a class. If vector is a class, then it has three orthogonal components, one along x-axis, one along y-axis, and one along z-axis. So a vector has three components in three directions. This is what we know. So there are three components of vector. Now, if I have two vectors, okay, so if I have, I mean, it is tough, so I'll take it out. Now, if I have, if I have, if I have two vectors, one is black and one is blue, one is black and one is blue. If I say I want dot product, then vector must be in same direction, and then we calculate the, we multiply the magnitude. That is the idea. So if vector are in same direction, can we see there is no area in between the vector? Now there is an, if I take out the vector, then we get the area formation between. If there is an angle theta, then there is an area that is getting formed in between this. Now, if it is going like this, the area that is formed is a rectangle. Can we see now? Okay. So, area between these two is a rectangle. Now, as we make like this, then area between these two is parallelogram. Okay. So, area between these two is like this. If I make, then now top, if I add, top if I do a flat line, a line parallel to this, then it is a parallelogram. But if it is 90-degree, then it is a rectangle. Now if I do like bend like this, then it will come as a parallelogram. Can we see? But if they coincide each other, then it is like there is no area. But this is the dot product. Dot product is if two vectors are in same direction, then multiplication of their magnitude is dot product. But cross product, if two vectors are perpendicular to each other, then multiplication of their magnitude is cross product. So if there is a vector called A and there is a vector called B, vector A, vector B, A cross B, A cross B. Now, if B and A are perpendicular to each other, this is what cross product. Cross means two vectors must be perpendicular to each other. So they are perpendicular. One is along x-axis and one is along y-axis. If they are perpendicular to each other, then multiplication of their magnitude is the cross product. Okay. Now, since it constitutes an area, can we see this is an area? Okay. If they constitute an area, then the direction of the net vector. If they constitute an area, then okay. If they constitute an area, so area means there is a surface. If there is a surface, then surface has a direction. Okay, the direction of the surface is perpendicular to the surface. Can we see? If there is a surface, then direction of the surface is perpendicular to the surface. If there is a surface, direction of the surface is perpendicular. I can keep it on it. So direction of the surface is perpendicular to surface. It is obvious, right? So if I have two vectors perpendicular to each other, and if two vectors are perpendicular to each other, then cross product is multiplication of their magnitude. If there is a vector called A and there is a vector called B, then A cross B. There is a vector called A and there is a vector called B, then A cross B, if they are perpendicular to each other, then it is not cross is nothing but multiplication of their magnitude. So magnitude of A and magnitude of B. If A has three components, now later we'll talk about the component. So magnitude of whatever the magnitude of A is, magnitude of whatever the length or power of the vector, and B is length or power of the vector. If that we know, then magnitude of A and magnitude of B. Magnitude of A and magnitude of B is A cross B. Okay. Oh, now our story really starts now. Okay, now vector is like this. They are not perpendicular to each other. Okay, how we can calculate the A cross B? A cross B. A dot B. Both vector must be in same direction. If we want that, then A dot B. B cos theta is in, now they are in same direction. Okay. Now A cross B. B sin theta, this is theta. A B. B cos theta, same direction. B sin theta, 90-degree direction. Okay, so but the length will reduce because b sin theta maximum is 1. So if there is an angle 30, 40, 45, then the sin theta will be less than 1. So b sin theta will be less than b. So if I have two vectors and there is an angle between them is theta, the two vectors angle between them is theta, then A and B. Then B cos theta, same direction, hypotenuse. Okay, so hypotenuse into cos theta, that is base. And B sin theta means hypotenuse into sin theta is perpendicular. Perpendicular by hypotenuse is sin theta. So we get the perpendicular component of any vector through multiplying it by sin theta. So A magnitude, B magnitude and sin theta is A cross B. Simple. Okay, what is the direction of the resultant vector? Because it will lead to a vector because there is an area. If there are two vectors like that, then there is an area in between. What is the area in between? So area in between is, if there are two vectors like this, then area in between is parallelogram, how they are making. So this is parallelogram. Now if I connect like this, it will become a parallelogram. So whatever the area of the parallelogram is the area of the so that is actually that is the resultant of cross product. So what is the cross product between these two? One is b sin theta, whatever it comes in, and then multiply the, then now we get the vertical component of this vector. So but now if there is a vector called A and B, then B sin theta results in another vector whose magnitude, whose direction is perpendicular to A and whose strength is B sin theta. So B sin theta into A is A cross B, or the area of the parallelogram. So area of the parallelogram is nothing but base by height. So height is same as B sin theta. So whatever area it is making, like, okay, so there is two vector now. Can we see? There is one vector like this and another vector like this. There is one vector like this, that is B, and another vector is like this, that is A. This is origin. This is origin. If this is origin, this is A. If this is A, then this is B. If this is A and this is B, then we get the area. So this is half of it. Now we'll make the full parallelogram. That is the area, I believe. Okay, whatsoever means that is the idea. So if there are two vectors, then whatever parallelogram we make, that is the area. So now area, the idea of showing this is it has a direction. Can we see? The direction of the resultant vector is perpendicular to the if there is a two vector, if there is two vector like this, if there is two vector like this, then if I see the paper, that is the plane on which these two vectors lie. Okay, if this is A and this is B, then this is the plane in which A and B both lie. So the direction of the net vector is perpendicular to the plane in which A and B lie. Now as we move these vectors, the plane of the A and B is also moving. Can we see? Now the plane is like this. Now plane is like this. Now plane is like this. So there the cross product vector direction would be perpendicular to the plane. So A cross B is B is B vector along the perpendicular direction. So if two vectors are perpendicular to each other, then their cross product is multiplication of their magnitude. If two vectors are in same direction, then dot product is multiplication of their magnitude. If two vectors are perpendicular to each other, orthogonal to each other, then their cross product is multiplication of their magnitude. So if two vectors are in same direction, then their cross product is 0, right? So if these two vectors are in same direction, then this vector's component along orthogonal to this component is 0. There is no vertical component. They are exactly coinciding each other. If they are exactly coinciding each other, means there is no vertical component. Now if I move like this, then if it is like this, then vertical component is this big. If it is like this, then vertical component is this big. If like this, then this is the vertical component. So as the angle is increasing, the vertical component is growing. So whatever the vertical, if two vectors, so this we are not calculating at all. This is not in the picture. This vector and orthogonal vector. So whatever this vector is contributing to this orthogonal vector, that is we are calculating. So A cross B, then I would say pseudo B. Here there is a pseudo B. A cross pseudo B. So if they are in same direction, pseudo B is 0 because it has no component along y-axis. As the angle is growing, the pseudo B is growing. So whatever the strength of the pseudo B is A cross pseudo B. Now if it is at 90 degree orthogonal, then pseudo B is B. Okay, and what is the direction of the net? So since it brings an area, so if angle is not 90 degree, it is a parallelogram. But if angle is 90 degree, then it is a rectangle. Okay, whatever the area is, that is anyway, that is A cross B, A into B. And whatever the perpendicular to the surface, okay, that is the direction of the vector. Now, the concept is, can we repeat same thing when we consider the component? I don't want to calculate A's magnitude, B magnitude through Pythagoras theorem. Anyway, that will be in components only, then sine theta and so on. If I have three components of A1, A2, A3, and I have three components of B, B1, B2, B3. If A component has A1, A2, A3 and B1 has component B1, B2, B3, then anyway if I calculate the magnitude of A, it will come as A1 square, A2 square, A3 square, square root. If I calculate the magnitude of B, then B1 square, B2 square. So B1, B2, B3, A1, A2, A3, anyway it is coming into the picture. Can we calculate everything in terms of A1, A2, A3, B1, B2, B3? I don't want this cos theta, sin theta, and those. Who will go and calculate their angle and then? So, can we do all kind of mathematics through orthogonal components only? That is the actually the matter of research, and we are proceeding in that direction. Now, A is A1, A2, A3, three component, B1, B2, B3 is three. Suppose that A is alpha I. There is a vector the way we did in dot product. So there is a vector along x-axis that is alpha I. There is another vector called B. There is a vector called B, and there is a one vector called alpha I. Alpha I means it has a strength of alpha and it is in direction of x-axis. And there is a vector B. What is alpha I? A dot B, A cross B. What is alpha I B? What is cross product of alpha I, which is a vector, and B? That is the question. Now, B has three components: B1, B2, B3. Now, all three components we will try with the alpha. Okay. So, alpha would entertain. Now, all three components we will see that how much they contribute in the orthogonal to B has three components. B1 in x direction, B2 in y direction, and B3 in z direction. If their three vectors are there, if they meet at origin and wherever they go, that is B. So that it has three components, that is B1, B2 and B3. So if B is a vector which has three components B1, B2, B3, and there is a one vector that is alpha I, a vector that is moving in I direction. So alpha I. What is alpha I cross product B? Alpha I cross B. Alpha I cross B1, B2, B3. Alpha I cross B. B is a vector which has three components B1, B2, B3, where alpha is a vector which has only one component, that is alpha. Now, how we can do? Now, the cross product of two vectors means if two vectors are orthogonal to each other, then multiplication of their magnitude. If two vectors are not orthogonal to each other, then through sine theta we try to find out how much it has a sense, how much this energy, the energy along B direction has, how much energy someone would sense if he is standing in y direction. This is what we keep on saying. So if this is vector A, if this is vector B, then orthogonal to A, there is an axis. Okay. If this is the axis, if someone is standing on this axis, then because B is a vector means energy that is flowing in a direction and has a strength. If B is a flowing, okay, or is you can say sunlight or wind, then how much this energy essence we see in an axis that is orthogonal to A. Okay, so for that, if angle is theta, then that is sine theta. So this is what we are seeing. Now let's compute component by component. So we want alpha I cross another vector called B. Now B has three components. So B1. So B1 is in B1I. Okay, in X. So B1 has same direction as alpha. So 0. Both have to be in orthogonal, but if they are not orthogonal, we'll try to find out orthogonal through sine theta. If theta is 0, same direction, then their cross product is 0. So alpha I cross B, where B has three components B1, B2, B3, where B1 is along I axis, B2 along J axis, and B3 along K axis, then alpha B1 is 0 because both are they are in same direction, collinear. Now alpha cross B2. So alpha, and now B1 we tried with the alpha. How much it will come? It is 0. B2 is along y direction and alpha is along x direction. So their cross will come. So now if this is alpha x axis and this is B2, okay, B2 along y axis, their cross product will be alpha into B2 because angle is 90 degree, 1, sine theta is 1, alpha into B2, and their direction will be z direction. So this direction along me. Okay, so there is a left hand rule. So if this is x axis and this is y axis, then this is z axis. If cross product of x y will go along z direction, so it will go along z direction. So alpha into beta 2, sorry, alpha into b2 is one component that will go in k direction, z direction. Now next one, b3 will try. b1 we tried 0, b2 successful, and its magnitude is alpha b2, it will go in z direction. b3, b3 is in z direction and alpha is in I direction. Again 90 degree. If it is 90 degree, then I cross j, I cross I, I cross j is k, j cross k is I, then I cross k is minus j. Okay, opposite. So now we are doing alpha I and b3. So b3 is in k direction, z direction, and alpha is in I direction. Since it is 90 degree in between, so they are orthogonal to each other. If orthogonal to each other, the multiplication of their magnitude would be the cross product. If that is true, then alpha b3 is the magnitude where direction is I cross k, that is minus j. So negative of the y-axis. So if this is y-axis, if this is x-axis and this is y-axis, this is x-axis, then in negative direction it will result in. So what we are getting now? So alpha b2 in k direction and alpha b3 in minus j direction. So it will come as alpha b minus alpha b3j plus alpha b2 k. So this is the cross product. So we are getting a vector which has two components. One is alpha b3. Okay, so one has component alpha b3 in minus j direction and one is alpha b2 in k direction. So if I take two vector which is moving in my y minus y direction, so it is coming from positive y direction, it is at center now and it has a strength as alpha b3, and there is another that is coming from minus z axis going toward positive z axis and it has a strength of alpha b2. If they meet and wherever they go, that is the direction of the resultant cross product. So cross product has two, cross product of two vector is a vector, okay, and the cross product of two vector is a vector which has the component. So cross product of alpha I and b is itself a vector which has two components. One is alpha b2 alpha b2 in z direction, one component, and minus alpha b3 in minus y direction, minus j direction. So whatever the position vector comes in with this calculation, that is the resultant vector. Now, if these two are the components, then what is the net cross product? So, using Pythagoras theorem, we can square these two and calculate the square root. So, that is the resultant. Or we can kind of, uh, uh, kind of, we can, I mean, we can calculate the hypotenuse. So, whatever comes, so that is the Pythagoras theorem. So, if two vectors are perpendicular to each other, then cross product of two vectors are the multiplication of the magnitude. This is what we learned. That's how we tried. First we tried b1 with alpha. They are in same direction, so 0. b2 with alpha, they are orthogonal, so b2 into alpha. Simple multiplication. Then b3k with alpha I, since k and I are orthogonal to each other, so b3 alpha. So just multiply. This is a cross product. So cross product is nothing but we have to calculate this way. Now suppose that instead of alpha I, okay, we calculated alpha I cross B. Instead of alpha I, it is A cross B. A cross B. A vector cross V vector. A1I plus A2J plus A3K, three components, A1, A2, A3. And there, three components, B1, B2, B3. Now, we have to calculate the cross product. Now, we will do component by component. So, first we will try B1 against all three components of A, B2 and B3. Means how much we can improve in so that it will be orthogonal. But now there is no angle wangle because all three components are orthogonal. Okay, so first we'll try B1 against all A1 to A3. So B1, A1, same direction, no result. B1, A2, B1, A2, B1, A3, whatever the direction we can calculate. Now B2, B2, A1, something, B2, B2 gone, B2, A3, something. Now, again, B3, A1, something, B3, A2, something, B3, B3 gone. So, six things we are getting. Six things we are getting, and we have three components. Means in each component, we have two kind of multiplication we are getting, like A1, B2, and A2, B1 in K direction. A1, B2 minus A2, B1 in K direction. Okay, so this is what we get like that. So two component we get along each direction. So for K direction it is A1, B2 minus A2, B1. Okay, because A3, B3 has no meaning in K direction. If I talk about I direction, okay, so that will come as A2, B3 minus A3, B2, because A1 has no meaning in the I direction. Like that, we get subtraction in I, J and K. Why there is subtraction? There is subtraction because if I have if I have any surface has two sides. If this is a surface and if the surface is along in, if this is x-axis, this is y-axis and this is z-axis. If there is a surface on xy plane, then surface has direction, one is positive z-axis and one is negative z-axis. If this is a surface, then it has one in positive x-axis and negative x-axis. Like if there is a surface in xz plane, there is positive x-axis and negative x-axis. It has two normal vectors. So first is A1, B2 means positive x-axis and A2, B1 in negative z-axis. That we have to calculate, and then whatever come, that is the kth component of the resultant vector. Like that, ith component and jth component, that we have to calculate. So if I am looking for two vectors kind of two vector cross product, then first way is, if I know the theta angle between them, just calculate the sine theta, whatever comes in, and then whatever we get, the its essence of this, essence of this vector, this is B vector. So this vector is powerful, but this power, what is the, this power is orthogonal to the A vector. That power is B sine theta. Whatever B sine theta magnitude comes, multiplied by A magnitude, that is the cross product. So B sine theta means magnitude of B sine theta and cos A. So magnitude of B is B1 square, B2 square, B3 square, square root. Magnitude of A is A1 square plus A2 square plus A3 square, square root into sine theta. Now this is one way. Another way is we have to calculate component by component. A cross B means B's all component we have to try against A's component. So first B1 will try. So B1 against A1 0, B1 against A2, B1 into A2 because it is perpendicular to each other. Okay, so I would say A2 into B1. So A2J into B1I. So J into I is minus K. So A2 minus A2 B1. This is what we are saying. Minus A2 into B1. Now we'll try B3. Okay, so B2, B1 we are trying. So B1 A1, B1 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 A1, B1 A2, and B1 A3. B2 A1, B2 A2, B3 B2 A3. Then B3 B A1, B3 A2, and B3 B3. But we have to try from A to B direction. Okay, so this is what we are trying. So this way we come to kind of something like A1 B2 minus A2 B1 in K direction. A1 A1 B3 minus A3 B1, okay, in Z direction, in Y direction, and A2 B3 minus A3 B2 in I direction. So this is what we get, six things. So if I subtract, then we get three component. We get three component because the if there is a B, then B has component along x-axis, y-axis, and z-axis. Okay, x-axis, y-axis, and z-axis. It has three components. Like that, A has component along x-axis, y-axis, and z-axis. Now, if we go for multiplication, okay, so 3 into 3, okay, 1 will get multiplied 3 times, then 3 times 3. So 9 multiplication we are getting. Out of 9 multiplication, 3 are null because same direction vector will result in cross product of 0. So we are as calculating cross product of 3 vector into 3 vector as if there are 3 vector. 3 vectors separate and 3 vectors separate. So that's how we are calculating. So one vector getting cross product with the 3 other vector, another vector getting cross product with 3 other vectors. So 9 times 3 are becoming 0. Only 6 are remaining. If 6 are remaining, then for one component for J, so A, if A has kind of I component, A has X component, okay, and B has Y component. A has X component, B has Y component, then B, I cross Y is K. Okay, if A has Y component and B has X component, then Y cross I is minus K. So if okay, so if X if A vector and B vector, A vector's X component and B vector Y component, if they cross each other, then resultant vector will go in positive Z axis. If A's Y component and B's X component, if they cross, their resultant will go in the negative Z direction. Now, we have to subtract to get the actual component in the Z direction. Like that, we have to subtract for the I and J. Then it will resultant in like A2 B3 minus A3 B2 along I axis. Okay, A1 B3 minus A3 B1 along y axis, and A2 B3 minus A2 B3 minus A3 B2 along z direction. Okay, so why I remember? Because it forms a matrix and only determinant we are calculating. This is what we are doing. So if there is a matrix where it is 3 by 3, okay, first is IJK and then A1, 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 A2, A3, B1, B2, B3. Okay, so A1, A2, A3, B1, B2, B3. To get for the I, then we have to get the first row, first column determinant that will come as A2, B3 minus A3, B2. If I want to calculate for the, this is for the I axis. But if I want to calculate, you understand, right? If there is a matrix 3 by 3 where the first is IJK and then A1, A2, A3 and B1, B2, B3. If I want to calculate in I direction, then first row and first column that we have to take into the mark, then we have to calculate the determinant. That is A2, B3 and B2, B2, A3. Now, if I want to calculate along y direction, then middle one we have to take and then we calculate the determinant. That will be A1 B3 minus A3 B1. If I want to calculate in z direction, then the bottom column, bottom row and last column we have to mark and then we calculate the determinant. That will come as A1 B2 minus A2 B3. Okay, so whatever the notation we see in material, we'll proceed on it. So this is not the end of cross product. We'll proceed on it. But the idea is whatever we are doing in mathematics, matrix multiplication, logarithmic table, sinusoidal, vector, everything is notation. But the actual, the we say that a spatial imagination, the spatial its interpretation, that is important. So what is cross product? That if two vectors are perpendicular to each other, this is the basic thing. If two vectors are perpendicular to each other, then multiplication of their magnitude is the cross product. What is the direction of the cross product? Whatever the surface it is making with the cross product, the surface that is comes. So surface of two vector, if there are two vectors, there is a surface along the two vectors. Okay, if two vector is moving in the space somewhere, then their surface is on which these two vectors are lying. So if two vectors are x and y, then their surface is called xy plane. If two vector is x and z, their surface is called xz plane, like yz plane. Okay, so if there is two vectors, if surface is z, y and x, then it is yx plane. Yx plane direction is negative in the z direction. Can we see this? So if there is a vector, if there is a vector, this is x-axis, black one, and this is y-axis, blue one. If blue one is y-axis, this is black axis, their surface is xy plane. But if blue is y-axis, and if black is y-axis and blue is x-axis, then, okay, so if it is A and it is B, then it has a surface, but the direction is minus z direction. This is y-x plane because we want black cross blue. We want black cross blue. Everywhere we want black cross blue. If black is x-axis and blue is y-axis, this is xy plane. So resultant vector will be in positive z direction. If if A is y direction and B is in x direction, this is y-x plane. And y-x plane, then the resultant vector will go in the negative z direction. So two vector, if they form, if they are position vector of two vector, if we know, position vector means one side is origin. One side is origin, then this is a position vector. Otherwise, it is a displacement vector. So if two vector, if we know, then, and if they are perpendicular to each other, if they are not, we will make them perpendicular to each other. If they are perpendicular to each other, their multiplication of their magnitude is the cross product. Direction of the cross product is the surface what these two vector make. That surface normal is the direction of the perpendicular. Or if we have the way we calculated, if we calculate the cross product through component, then A1 B2 minus A2 B1, that is x component. Then A2 B3 minus A3 B2, that is x component. Then A1 B3 minus A3 B1, that is y component. And A2 B3 and A1 B2 minus A2 B1 is the z component. If there are three components, then the magnitude of the vector would be these three components square root, Pythagoras theorem. And direction of the this resultant vector is three components position. Three components now separate magnitude we know. In I direction, what is the magnitude? In z direction, what is the magnitude? In k direction, what is the magnitude? If three magnitude we know, if three magnitude are alpha, beta, gamma, then alpha, beta, gamma, a point I have to draw and then what is the position vector, that is the resultant cross product as far as mathematics is concerned. But as far as spatial calculation is concerned, then it is whatever the surface these two vectors are making, that surface normal is the resultant cross product, or you can calculate it mathematically. So, okay, so we'll see the example later. I believe it's all right. Then we'll see the mathematics calculation and we'll see the example